Let us simulate this simple RLC series circuit in LtSpice. Here is our LtSpice. Open a new file and then select the register button from the toolbar. Rotate the register and place it wherever you like. Select inductor, rotate and place wherever you like. Select capacitor and place wherever you like. Then to get a voltage source, click on this component button and type voltage source or signal, and you will get an AC voltage source. Click on OK and press this source wherever you like. Then right click on the source and set the amplitude of the voltage to say 100 volt and frequency to 50 Hertz. Okay. Then right click on the register, set the value to a desired value, say 20 ohm. Right click on the inductor and set the value to say 0.1 Henry. Right click on the capacitor and set the value to say 300 microfarad. Then we have to connect these components to complete the circuit. For that, select this wire button, and if you want to join these two terminals, just click on them one after another and they are joined. In the same way, I can join this with this terminal and then this terminal with this terminal and then this terminal with this terminal. My circuit is complete, but before I can simulate this circuit, I need a ground point or a reference point. For that, select this ground button and place this ground symbol wherever you like, and then with this wire, join this ground point to some point in your circuit. This will set this point to have zero potential or reference potential. It is important and required for the simulation to work. Then to run the simulation, you click on this run button and set the duration of simulation. You can set the duration or time to say 0.1 second. Okay, and then the simulation is working. Now if I bring my cursor say at this point of this terminal of my source, and if I click at this terminal on this graph, I will get the waveform of how the potential at this terminal is varying with time. You see, the potential is varying sinusoidally with peak value of 100 volt as given by the scale, and it is varying with a frequency of 50 Hertz. X-axis is time in millisecond. Now if I want to get the current through this inductor, I have to bring my cursor on top of the inductor and notice the direction of the red arrow being shown, which is in the direction from left to right. Now if I click on this inductor, I will get the current waveform through this inductor in the direction from left to right. So I click, and this blue waveform here is giving me the value of current through the inductor in the direction left to right. The peak value is around 3.2 ampere, which you can read from this scale. Suppose you want to measure the potential difference between two terminals, for example between the two ends of this capacitor. For that you have to first click on one end of the capacitor and hold the mouse and drag it and release the mouse at the other end of the capacitor. Then this graph, this red graph, is showing me the waveform representing the voltage difference between the left and right end of this capacitor. Left end minus right end. Okay, and you can read the peak value of this voltage from this scale. Now suppose I want to calculate the power consumed in this resistance. For that I have to get the value of the current through this resistance and the potential difference across this resistance. I have to multiply this potential difference and the current and then take the average value of the product of the voltage difference and the current. For that, first let me come to this label button, okay, and then give some name, for example A, okay, and then click on one end of this resistance and then again go to this label, give another name, for example B, okay, and click on this other end of this resistance. Now this end of this resistance is named as A and the other end is named as B. Next, come here and click on this LtSpice directive button. A window will appear. Here we have to type some command. I will put the following command: .meas for measurement or measure, then space, then give some variable name, for example P for power, then space, then AVG for average, then space, then inside bracket I have VA minus VB, that means voltage of node A minus voltage of node B, star multiply I in bracket R1, that is current through R1. So I am multiplying the voltage difference between node A and node B with the current through R1 and then taking the average of that quantity over time. Then click on OK and place this command wherever you like. Notice this command, dot MEAS P average value of VA minus VB star current through R1. Then if I run this, okay, this circuit is running, and then I can go to view and SPICE error log. A new window will appear, and here you see the average value of VA minus VB multiplied with IR1 is 120.172 watt. So this is the value of the power or average power dissipated in this resistance.